Hi everyone, welcome to the channel. If this is your first time watching a video, I hope you'll stay to the end and consider subscribing for more chemistry content. In today's edition, we are looking at part 2 of my experimental design series. In part 1, we talked about variables, differentiating between an independent and a dependent variable. We also went in depth about graphing those variables, which one goes on which axis. So if you haven't seen that yet, you may want to check it out. But in this one, we're looking at constants and controls, two other essential pieces to any properly designed experiment. And it could be anything from a psychology experiment to one in biology or physics. Now I'm covering these two together because I noticed there's some confusion, there's some overlap here, and students frequently mistake one for the other. So by the end of this video, I hope that you're never going to make that kind of mistake, and we're going to ensure that you don't by going over some practice questions. Thanks for tuning in, and let's learn about controls and constants together.
What's up, everybody? Welcome to Neil's not so boring world of chemistry. Let's go into the lab and take a deeper look.
So for starters, let's think about an experimental question that we want to investigate. What about if we had mushrooms and we were interested in knowing a little bit more about how mushrooms grow in terms of their food? Our research question might be, how is mushroom growth affected by food source? Now, mushrooms, as you probably know, are saprophytes. They generally feed off of dead plant and animal matter. So in this experiment, I want you to think about the design. What would be some constants we would need to have in place in order to design an experiment that would answer this research question? Take a minute, think that over, come up with a brief list, and then I'll explain to you what a constant is, and you can see if you got this question right. Okay, do you have your list of constants? I'm going to give you mine, and I'm going to keep it brief. Three constants that I think would be essential to designing a good experiment that would answer this research question about food and its relationship to how mushrooms grow would be the following. I would want to make sure that all of the mushrooms I'm going to use in my experiment are the same exact type of mushroom. Next, I'd want to make sure that the amount of sunlight I'm exposing the mushrooms to is exactly the same. And lastly, I would also want to consider the humidity or amount of moisture in the air. I'd want to make sure that in terms of the atmosphere, these mushrooms are being exposed to the same amount of water. Okay, now those are just three constants. If we were really going to set this up, we could come up with a much more extensive list. Did your list match mine? If you're wondering what a constant is, think about the name. Constants are factors that we're going to keep consistent amongst all of the parts of our experiment. Now, in this case, our experimental subjects are mushrooms. In other experiments, they may be human beings, or mice, or rats, or even different beakers of chemicals. But a constant is always going to be something that is not varying from experimental setup to experimental setup. That's generally because we know about variables, and we only want one thing to be different amongst our test subjects. So we have our one variable, and everything else that we keep consistent is called a constant. Next, let's take a look at what control groups are and how they're very different from our constants. Now we're ready to learn about controls. In our experiment regarding food and how it affects mushroom growth, I'm going to set it up in the following way. For some of the mushrooms, I'm going to use typical soil, which no doubt contains some dead plant matter that they'll feed off of, but I'm going to be adding some extra dead ants to see if that impacts the growth. To another group of mushrooms, I'm going to be using the same typical soil, but in this group I'm going to add an excess of dead worms to see how that would affect the growth. So my question to you is, what's my control going to be? Now we know the control is not the same thing as the constants, right? We've already gone over what we would keep the same amongst the three groups of mushrooms. But what would the control be? Think about it and come back for an answer. So what did you say the control should be in this experiment? As you can see, for my control group, the mushrooms are going to be exposed to just typical soil with nothing excess added. What's the purpose of this? Why would I want to have mushrooms just growing in normal dirt when we're trying to figure out how we can change the way mushroom grows by adding something extra like worms or ants? So the purpose of a control or a control group is you need a standard of comparison. You want something within which nothing has been changed. It's totally ordinary, it's totally natural, so you can truly measure the impact of the variable that you're changing on, in this case, the growth of the mushrooms. And experiments, no matter whether you're doing them with humans, plants, animals, or fungus in this case, should always have a control, a standard group of subjects within which nothing has been shifted or altered from the normal everyday conditions. Now, this is not a constant, right? Remember, we said the constants were things like amount of sunlight, amount of moisture in the air, and the type of mushrooms. So you see the constants are the same amongst all the groups, including the control. But the control is a group where the variable that you're shifting is not included. It's not there. And you're only comparing based on what this particular organism or situation is like normally, not the way it's being manipulated in your experiment. All right, so before we practice, just one final point of clarification, because I think I know where some of the confusion is coming from on this topic. Some textbooks, some YouTube videos, some teachers talk about constants, but instead use the term controlled variables, and they mean the same thing. But that's confusing, right? Because we have this other thing called a control or a controlled group, and now we're calling this a controlled variable, and well, they just all kind of get jumbled up together. So let's just break this down and explain why they're different and what makes them different. So our constant is that thing amongst all of our groups in our experiment that we're going to keep the same, like our humidity, our sunlight, our type of mushroom in that example. Well, you can also call that a controlled variable, because if we wanted to, the type of mushroom could vary. We could make that our independent variable. The amount of humidity could vary. We could make that our independent variable. So these are things that could vary, but we're choosing to keep them the same. So we're controlling those potential variables. So while I always use the word constant because I think it's just, well, best to differentiate between constant and control group, if you hear controlled variable, it's just another way of saying something you're going to keep the same, something that's not a variable, something you don't want to change. On the other hand, a constant is not the same as a control or control group, right? The control or the control group is what we're using as a standard for comparison, a way to say, hey, did the change we made in our variable groups, our experimental groups, actually make a difference when compared to what normally happens in nature? So I hope that's clear for you. These are synonyms. Constants and controlled variables means the same thing, but a constant is not the same as a control or a control group. All right, let's practice and see if you got anything out of this video.
So let's read through this practice question together and then give you some time to come up with an answer and test your experimental design skills. We know that when copper is exposed to air for long periods of time, it forms this blue-green color on the outside, and we call that a patina. It's often seen on copper statues like the one to the right. An experiment is designed in which a chemist wants to learn more about how the color of copper might change when it's exposed to chemicals called acids. There are many different types of acids. The chemist is going to test 4 different pieces of copper metal, and each piece will be exposed to a different type of acid for 10 days. If there are any color changes, they will be observed and thoroughly documented. I'm asking you to come up with 3 things that should be held constant in this experiment. Also, think about an appropriate control. After you have your answer, continue watching to check your work. Okay, so for our practice question, here are some potential correct answers. Now, I've listed many constants even though I only asked you for 3. Some of the things that should not change when thinking about the 4 pieces of copper we're testing would be the temperature, the mass or amount of copper, the humidity or moisture in the air, how much sun are they exposed to, the purity of each piece of copper, the amount of acid we're putting on each of the pieces of copper, and finally the time of exposure, which we said will be 10 days. Now remember, our control is for comparison. We want a piece of copper that's going to just experience very standard normal conditions. And in this case, we would just want to have a piece of copper that's constant in all the same ways, and it's only being exposed to air. So there's going to be no added acid whatsoever. Did you get that right? I hope so. Thank you all for watching this video. You can follow me on Instagram at Neil's Not So Boring World of Chem to get updated every time I release a video. And if you have any questions or you want to leave a comment below, please do, and I'll be sure to respond to you. Thanks again. Have a great day.